So we are going to learn about the time series and sequence data and what is trend analysis. And we are going to learn about the similarity search and distance measures and how we can mine the text data. Time series and sequential data. What is the meaning by time series? Time series database. It is the data consists of sequence of values or sequences of event changing with time. So for example, I have classes on Monday, I have classes on Tuesday, I have classes on Wednesday. So there's a kind of sequence based on time. And the data is recorded at regular intervals. Regular intervals. What does it mean by regular intervals? So you can see the interval patterns. Let's say I want to have the data daily. So the data on daily base data is like the stock. Okay? We have the daily in the morning and the afternoon. Or we can have the data weekly. Weekly data. So it is also regular data. Or we can have the data monthly. So it's also regular. Or we can have the data yearly. Every year we collect the data and then we want to check last year. We want to check 2 years ago. We want to check 5 years ago. So it's regular. Or sometimes we want to check based on the hourly data. Or we want to check every minute. Or maybe you want to get the data every second. So it also can be considered as the regular intervals. The characteristics of the time series, we can have like trend, we have cycle, we have seasonal, we have irregular. So some applications can be in the financial, like stock price. And then I want to check the inflation. So the inflation means I want to know whether the price index is getting higher or lower. The biomedical, for example, you have the medical checkup every 1 year or every 2 years. So the hospital will record your blood pressure. Or the meteorological. You know, every day we know about the temperature. We know about the precipitation. We know about the wind speed and other things. So, those kind of things is in the time series database. So the time series, a time series can be illustrated as a time series graph, which describe a point moving with the passage of time. So it means if we have the data like this one, this is the observation data, and this is the time. And we know that in 1990, maybe this is the observation data about items. So the number of items has been sold is this amount. In 1995, the item has been sold as this one. In 2000, the item has been sold as this one, and so on. So we can see that maybe this data reflects the monthly data. So in 1990 January, 1990 February, 1990 March, April, May, June, and etc. So we can plot You can do the plotting like this one. So there are some categories of the time series movement. We can look at the trend. The trend means we want to see the long-term or trend movement with the trend curve. So trend means there's a growing pattern like this. So it is growing up because this is trend. Cyclic. So cyclic movement or cyclic variation. So it is the business cycle. For example, we have the business cycle every month, every early month, the beginning of month. So January 1st, February 1st, March 1st. So it's like the business cycle. But if you have the data, we may have like seasonal movement or seasonal variation. So we call this is the almost identical patterns that a time series appears to follow during corresponding months of the successive years. So for example, I have the data on summer, on maybe on summer there's a high demand, on winter there's low demand. Okay, this data resemble for the seasonal. So the seasonal is something like, we have the pattern that we can know, okay, sometimes it goes up, sometimes it goes down, and then it will recur. So there's a pattern to see this kind of seasonal. So every summer it goes up, every winter it goes down, and so on. Irregular or random movement. It means we do not see any patterns. So the patterns are not clear. So we call this is random or irregular. We can do some estimation on the trend analysis or the trend curve. There are three methods. The first is the freehand method. The meaning by freehand method means I have the actual data in 1972. The actual data is, this is the number of road accident, 2,493. In 1973, I have the data that road accident is 2,638 and so on. So I can do plot like this one. And then with the freehand method, I'm just fitting the curve by looking at the graph. Okay, I know the graph is going up like this one, then I can just make the line like this. So it means freehand method, it is based on my subjective analysis. It is costly and barely reliable for large-scale data mining. If you look at this data, it is from 1972 until 1978. Okay, it's only like 6 years. So it's okay because the data is small. We can just use the freehand method. But if the data is like 30 years, 50 years, so it is difficult. And this freehand method is not reliable. The other method, we call it the least square method. Least square, it means we want to find the curve minimizing the sum of square of the deviation of points. So if we have the point, this is the data, this is the actual 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 data, and let's suppose I have this line. So I know that this line can resemble for every of the actual data. But I would like to see the error. So the error is the gap between this actual data and the respective line. The gap between this actual data and the respective line. The gap between this data to the respective line. Then, if you can have the yi, this is the actual data, minus by the y prediction. In this case, the prediction is based on this line. So I can do the square. Okay, so this is the meaning by squares of the derivation of points. So we have the sum. It means I want to sum from I equals to 1 until n, until all the data. So this is the least square methods, or we call this is the error estimation. Usually we can just say this is the error estimation, but people say this is the least square method. We can have another method, we call it moving average. In the moving average, we can eliminate the cycle, we can eliminate seasonal, and we can eliminate the irregular patterns. And at the end, we need to check the loss of the end data. It is sensitive to outliers. So let's see one example about simple moving average. Let's suppose I have the 11 data. Period. Period means, this is period 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Maybe this is January, February, March, April, May, June, July, August, September, October, November. So this is the actual data. Maybe this is, let's say, the number of items that has been sold by the store. So in January, the store can sell 42 items. In February, the store can sell 40 items. In March, the store can sell 43 items, and so on. Now, we can use moving average. Starting from fourth period, one can start forecasting by using MA3. What is MA3? We call it MA. It is the moving average for 3 periods. It means I will do the summation 42, which is the data in the period 1, plus 40, which is the data in the period 2, plus 43, which is the data in the period 3, and I will divide with 3. So the result is 41.66667. So I will just round it up to 41.7. And I will use this one as the prediction for the period 4. Okay, so we get the value 41.7. How can we get this value 41? Since we know that this is the MA3, then the 41 is from the 40 plus 43 plus 40. 40 plus 43 plus 40 divided by 3. Then the result will be 41. And this value will be the prediction result of this MA3. And so on. So this one is obtained from 3, 4, 5. This value is obtained from 5, 5, 6. Okay. We call this is MA3 because we calculate this on the 3 periods. What about MA5? MA5 means we have the moving average for 5 periods. If we have 5 periods, then we have 1, 2, 3, 4, 5. So 42 plus 40 plus 43 plus 40 plus 41 divided by 5. And the result of this one will be in the period 6. What about this value? This value will be obtained from the period 2, 3, 4, 5, 6. What about this one? It will be from the period 3, 4, 5, 6, 7. Okay. And so on. So we have the forecast, or this is the prediction using the moving average 3 period, and this is the prediction using the moving average 5 period. And you can plot. So the blue color is the plot for the actual value, and then the pink color is the prediction using the moving average 3, and then the yellow is the moving average 5. Now, I want to know which one is better. MA3 or MA5? In order to check the better approach, we need to calculate the error rate. What is error rate? In the regression, you learn the error rate. We have the MAE. This is the mean absolute error. And then we have the MSE. This is mean square error. We have RMSE. It is root mean square error. Okay. So those kind of error formula can be implemented also in this forecasting. So I can measure the MSE, so the MAE, which is the Y hat, it is the prediction, minus by the actual. So Y is the actual and Y hat is the prediction result, either MA3 or MA5. And it will be divided by K. K is the number of the data. Okay. So let's see with the MA3. Since the data exists until period 11, so we can calculate the error from period 4 until 11. Because the prediction result start from 4, so we will check this one until 11. Because we do not have any data on the period 12, so we cannot check the error. Then we will do the error checking. What is the error checking? We will subtract 41.7 minus 40. And then we make absolute. 41 minus 41. 41.3 minus 39. And then absolute. 40 minus 46, absolute. 42 minus 44, absolute. 43 minus 45, absolute. 45 minus 38, absolute. And then 42.3 minus 40. And then we have 1 2, 3, 4, 5, 6, 7, 8. So we have 8 data. So we divide with 8. At the end, we can calculate the error, and the error is 2.9125. Okay. If you look at this MAE, which one is better, MA3 or MA5? So you need to calculate. The MA5, you need to calculate the prediction result minus by 39. 40.6 minus 46. 41.8 minus this one. 42 minus this one. 43 minus this one. 42.4 minus this one. So we have 1, 2, 3, 4, 5, 6. So you will divide with 6. And then you get a value. Okay. So here's the question, which one is better, MA3 or MA5? And the answer will be the lower error is the better. I just show you the calculation for the MA3, so you can calculate by yourself the MA5. And you can check this value and this value, which one is lower. So the lower is the better. And you can check if MA5 is the lower, then we will choose that MA5 is the better forecast method. Okay. Alternatively, we can use MSE, mean square error. The mean square error, we just subtract the value and then do the square. Again, if you have question, which one is better according to the MSE? MA3 or MA5? Then you can check the lower error is the better. Whenever we do the time series analysis, we can also use the similarity. You know about the Euclidean distance. You know about the Manhattan distance. So those are the similarity. So now we are going to learn the similarity search in the time series analysis. In the normal database, you can query finds the exact match. But when we are doing with the time series, it's difficult to find the exact match. Usually we use the similarity search. Similarity search finds data sequence that differ only slightly from the given query sequence. So there are two categories of the similarity queries. The first is, we call it whole matching. Whole means all data. So we want to check for all the data. Find a sequence that is similar to the query sequence. Subsequence matching. We call it subsequence because we want to make it partial, or we want to make sub. Find all pairs of similar sequences. Some application can be in the financial market. It can be in the market basket data analysis, in the scientific database, or in the medical diagnosis. So this is one example, okay, the subsequent matching. When we do the subsequent matching, let's say I have this time series x1, x2, x3, x4, x5, x6, 7, 8, 9, 10, 11, 12. So I want to know about every sequence, and I break the sequence into a set of pieces of window. We call it window, and the length is W. Let's say I want to check for every form. Okay, so this is form items. So the window length will be 4. Extract the features of the subsequent inside the window. So every 4 I will check, and then map its sequence to a trail in the feature space. So I can map. If it is the first, then I will have the distance. If it is the second map, then I will have another distance. If it is the third, it will have another distance, and so on. And then we will divide the trail for each sequence into sub-trails and represent each of them with minimum bounding rectangle. So if I have already the minimum bounding this one, yeah, I will check for every of this one, and then I will check again for the next 4. I will check for the next 4. I will check for the next 4. I will check for the next 4, and so on. And then later we will use multi-piece assembly algorithm to search for longer sequence matches. So we can use the distance, we can use the matrix profile distance to check which one is the more similar. So I will explain only one algorithm. We call it this dynamic time warping. Dynamic time warping. So in this case, we are trying this is the DTW. It is a distance method that compares amplitude of the first signal at the time t with the amplitude of second signal at the time t plus 1 and t minus 1, or t plus 2 and t minus 2. For example, if you use the Euclidean matching, you will just, this is the time. In the time t, for the red color, you will check the distance with the blue color. Maybe in the t plus 5, you will check this value in the red color and this value in the blue color. So it means you will check only based on the particular time. But when we use the dynamic time warping, we can check this is the time t. We want to check with the time 3 plus 5. So we can match whether t equals to the data in the t plus 5. The t plus 1, whether it equals to the data with t plus 6. So we call it, this is the dynamic time. This makes sure that it does not give low similarity score for signals with similar shape or different phase, because there will be some difference here, and we will check with it. This is the algorithm. So let's say I have two kinds of signals. I have P and Q. Maybe I can say this is the stock price. This is the stock price of a company S. This is a stock price of a company A. Okay. So the stock price is 1, 4, 5, 10, 9, 3, 2, 6, 8, 4. And then the company A, the price is 1, 7, 3, 4, 1, 10, 5, 4, 7, and 4. So when you plot, you can get this kind of plot. Okay. So the first, we need to make the empty cost matrix creation. What is the empty cost matrix creation? We have the P and we have the Q. So we plot for every of the data. the data on P, we have 1, 4, 5, 10, 9, 3, 2, 6, 8, and 4. The data on Q, we have 1, 7, 3, 4, 1, 5, 10, 5, 4, 7, and 4. Okay. So after we do this empty cost matrix, so we can do the cost calculation. The cost calculation, we need to fill the cost matrix using the formula starting from the left bottom column. So starting from the left bottom column. So we have the formula like this one. Mij equals to Pi minus Qj. So P in the particular I minus Qj, Q in the particular J, plus the minimum of Mi minus 1 J minus 1, Mi comma J minus 1, and Mi minus 1 comma J. Okay, I think I need more time to explain this one. Let me stop here. Let me just continue on Thursday.